Hello everybody, this is a cathode ray tube or a deflection tube, and we use this to carry out experiments with a beam of electrons and see how that beam is affected by an electric field or a magnetic field. So firstly, let's show you how to set it up. There are terminals at the rear of the tube. Now that's for a low voltage 6 volts supply, which just supplies energy to a heater in there that heats up a little metal wire, which will produce our electrons in the first place. So low voltage from this power unit, now it's called an EHT power unit, extra high tension, because it can go up to 5,000 volts. So we need to be really careful with this. But initially, our first voltage, 6 volts, is going to the heater at the back of the cathode ray tube. So there's my leads connected to the back of the deflection tube. You can see a little light has come on there. Actually the heater that's come on that will produce our electrons. Now we want to accelerate those electrons from the back of this electron gun through the anode, which is the positive terminal of the gun, and accelerate them across the screen. That screen is covered in a fluorescent coating which will glow a kind of lilac-y purple colour if electrons hit it. Now, in order to accelerate those electrons, we need a very high voltage. We need about 5,000 volts, and that 5,000 volts is connected from the rear of the electron gun to a connection over here, which is at the positive terminal of the electron gun. So we're being accelerated from the cathode to the anode by about 5,000 volts. And when we connect that, we have to make sure that we use these shrouded terminals. So it's not possible to touch them as you're plugging them in or unplugging them, because very high voltage here. So 5,000 volts, let's plug it in. Right, that's me plugged in with my shrouded terminals. I have got the negative terminal connected to the negative terminal on the back of the deflection tube, and the positive 5,000 volts is going to the, let me see it there, positive terminal on the anode. Very careful, do not turn it on, do not increase the voltage until we are ready. And we are ready. So if I increase that voltage, and I can show both at the same time, I increase the voltage to, there's 1,000 volts. Nothing really on the screen yet. So let's keep going. There's 2,000 volts. And we're beginning to see a faint kind of lilac-y beam on the screen. Let's keep going. We're all the way up to 5,000. 3,000, we've already seen our beam there, and we could go all the way up to 5,000 volts, or the maximum that this particular EHT can produce, 4.72 kilovolts. And then we're seeing quite a strong beam across that fluorescent screen. The electrons themselves are invisible, but when those electrons hit the fluorescent coating, they make that coating glow a purple colour. So that's our deflection tube set up to accelerate electrons through the electron gun, and those electrons travel in a straight line at a very high velocity across that fluorescent screen. Now that electron beam can be deflected either by connecting an electric field across the top and bottom terminals of the deflection tube, or it can be deflected using a magnetic field. So just with a permanent magnet, or we could control that magnetic field by using some arrangement of an electromagnet. Now, this apparatus is designed to be used with these two coils of wire, which when a current passes through them will become electromagnets. And so we can insert these into the apparatus and use the current passing through these coils to produce a magnetic field that will deflect this beam. Let's set it up. So these coils fit in this location at the front and at the back of the deflection tube. Let me set it up. Alright, I now have both of those Helmholtz coils set up and attached to the apparatus. Now those two coils have to be connected in series. So one wire has to come out of one of those coils. That comes out of the Z terminal on this side, and it goes into, you can see that around the other side, it goes into the Z terminal on the other side, so that these are in series. And the other side is connected to a battery pack, just a 6-volt battery pack, through a variable resistor, and that's going to the other side of the Helmholtz coils. So those two coils are in series with that 6-volt battery pack and this 8-ohm rheostat. Now when we turn that on, always make sure it's turned down and switched off before you're ready to start. So turn on and switch on. If we go up to, say, 4,000 volts, okay, as close as I can, 4,000 volts, there's my undeflected beam. But if I am to turn on the current to these Helmholtz coils from just a low current from the 6-volt battery, then let's plug it in. What's your beam? There's our beam. Our beam is deflected in a curved path, and the direction of that curved path shows us the force that's acting on the beam of electrons by the magnetic field. And we can use our right-hand rule to give us an idea of the direction of the magnetic field that's acting on that beam of electrons. So if I use my right-hand rule, remember, says if my first finger is the direction of the field, my second finger is the direction of the charges, and my thumb shows me the direction of the force, the magnetic force on those charges. So if my field was going through these Helmholtz coils, my electrons are moving in this direction, so the beam would be forced up. Now that's not what's happening, the beam's been forced down, so therefore the magnetic field direction must be coming towards me. So it's coming from the back Helmholtz coil through the front Helmholtz coil. That's forcing the beam downwards. If I was to reverse the current by swapping the terminals on my battery, let's just do that very quickly, then we should see that my beam is deflected up the way. And again, right hand rule, my first finger shows me the direction of the field, second finger shows me the direction of the charges, that's the electrons, and the force is up the way. That's the deflection tube demonstrating the force on a moving charge in a magnetic field.